Hello everyone, welcome to BEC Lab 5B. Today we are going to see the PNP BJT output characteristics for common emitter configuration, the procedure for LT spice simulation. So this is my circuit setup for BJT output characteristics. So if you all have already done for the input characteristics, there are minor changes, or else I'll explain from start. Okay, so we need to set up this circuit schematic in LT-Spice. So you need to start collecting the components. So you can select the voltages. So type voltage in your component library and drag it over here onto the LT-Spice schematic. So you require two voltage sources, VVB and VCC, and two resistors, RB and RC. So RB will be around 100 kilo ohm, RC will be around 10 kilo ohm, and you need to select PNP transistor from the component library. So place everything here, connect them with a wire, connect the ground, and keep it ready. Okay, so after the circuit is ready, you need to right click on the voltage source VBB, click on advance, and there will be an option of none. Click on that none. So click on OK. So similarly do the same thing for VCC source. Right click on the VCC source, click on advance. So there will be option for none. Click on that and click on OK. So this step will ensure that, right now whatever we have done will ensure that the voltage sources, the DC voltage sources, VBB and VCC can be varied. Okay, they are not fixed value. Next step is we need to select the PNP transistor, a practical PNP transistor commercially available, which is BC557B from the component library. So this is the procedure. We will follow this. I have repeated that in the input characteristics. I'll do that again. So to select the transistor BC557B, you need to right click on this transistor. So right click on the PNP BJT symbol, click on pick a new transistor, scroll down and locate BC557B transistor. So and click on OK. So the once you click on OK, the number will appear onto the schematic, that is BC557B. Okay, so this means our circuit is ready and we have to only label it now. So label base, collector and emitter terminals of PNP transistor. This is wrong. This should be PNP BJT as base, collector and emitter. So that's how we do it over here. Base, collector and emitter. That is very important for plotting. So you need to right click on the wire, add label and add label net and then enter a label. Okay, let me walk through the procedure. So to add a label, right click on the wire. It should be right click on the wire, click on the label net, enter label and click on OK. So this is the small procedure to add the label. Once your circuit is ready, you need to simulate it now, right? So go to simulate, click on run, select DC sweep. Now be very, very careful over here. Remember, we have named the voltage sources as capital VCC and capital VBB. Now is the time to use that because it has to be varied. So you need to enter the name of the first source to sweep. This will be VCC. The type of sweep will be linear. Start value will be 0. Stop value will be 10 and increment will be 0.1. Similarly, enter the second source to be sweep as VBB. Type of the sweep will be linear. Start value 0.5. Stop value around 2 and increment will be 0.5. So both the sources has to be varied as first source, enter the details for the first as well as the second source. So why do we do this? This step means that we can vary the value of VCC from 0 to 10 in the steps of 0.1, and similarly we can vary the value of VBB source from 0.5 to 2 in the steps of 0.5. So once this is over, click on OK. So the following statement will appear, that is .dc VCC 010 0.1 space VBB space 0 space 2 space 0.1. This will appear on the schematic. At the same time, a new blank window will appear with x-axis going from 0 to 10 volts. Okay, so that means we are now ready for plotting the output characteristics. So output characteristics is IC versus VCE. So after the blank window will appear with x-axis going from 0 to 10 volts, you need to right click anywhere inside that blank waveform window. Click on add trace. Now you will have many options. Locate IC of Q1. So you need to select IC of Q1. click on OK, you will observe a curve immediately of IC versus VCC. With this curve will look like this, where VCC is going from 0 to 10 and IC is all negative values in milliamperes. But in reality, we wish to plot IC, the output current versus the output voltage, that is IC versus VCE. To do that, you need to right click on this plot, existing plot, right click on the x-axis of the plot. Now the quantity to be plotted will be VCC. Now please change it. There is option to change it. Change it to V of C. So V of bracket C. So you need to do that. Now what is C? C is nothing but your collector label. And while doing this, click on OK. Once you do click on OK, your desired IC versus VCE plot will appear. So it will look something like this. So it will be the plot in the third quadrant where IC and VCE are both negative. And that is what is predicted. So you have this 4 family of plots, the IB4, IB3 for what the constant values of these IB1 to IB4. So one might wonder that why you have not plotted V of CE. Basically, the emitter terminal is grounded, so your voltage across collector and emitter is same as voltage across the collector terminal. Hence, this is the plot of IC versus VCE only. Now, as we can see that this is output characteristics, it means that output current versus output voltage, keeping an input current constant. So here we are keeping the input current constant by keeping the input voltage constant. So basically we keep VBB constant. That will make sure that we have IB also constant. So, see this step. So this step will make sure that VBB is constant. That will make sure that IB is also constant for this output characteristics. So once you have this output characteristics, select one curve, not the first one, not the top one, not the bottom one, in between, whatever curve you have, you select that and measure the value of IC for different values of VEC. Now remember carefully, okay, I think I have made a terrible mistake over here. This x-axis should be VCE and the y-axis should be IC. So please change that. Here I have made a mistake. Extremely sorry for that. Again, I am repeating. I will annotate it over here. So I will write over here. This will be VCE. Okay. So this should be VCE and this one will be IC. So see to it that why, because y-axis is my current and x-axis is my voltage. So see to it that this mistake was unintentional. So please see to it that this is not happening in your case. Y-axis is always the current over here. So apart from that, once you get this, so note for different values of VEC, note down the values of IC. So basically this VCE is negative. So VEC will all be positive values. For these many values, I'll just clear the drawing now. Okay, I'll click on the close annotations. Okay, fine. So for different values of VC, note down the values of IC. So this completes your, let me clear the drawings. This completes the procedure for the, PNP transistor BJT output characteristics for common emitter configuration. So that's it for this online session. Next time we'll see another characteristics of NPN transistor in different configuration. Until then, have a good day and thank you.